turn it over to Alex Pinkney now. So to introduce the next guest, he's from a familiar group here at DocEng with the University of Nottingham. And just like there's a steering committee and a program committee for DocEng, this is nice because with Alex here, we have a member of the program committee to join Matthew and Stephen Bagley and myself on the steering committee of the people who bag on David Brailsford behind his back. So it's kind of analogous to the conference in general, and this will be our last talk for the afternoon.
Right, thanks Steve. Okay, so hopefully the title will become apparent as I go into the talk. It's fairly long. But okay, as we all know, I'm sure, electronic documents are effectively, they're ubiquitous nowadays. There's loads of devices you can view them on. I've seen a few iPads around. People have got Kindles. You can view things on your mobile phone. Many of these are battery powered. Oh, sorry. Okay, so many of these devices are now are battery powered. So and also, unlike the 10 years ago, Microsoft brought out a tablet PC, never really caught on. iPads, really, you see them everywhere nowadays. So we can really broadly categorise documents into two formats. There's PDF-like documents and there's HTML-like documents. So HTML documents tend to, well, their appearance is very much dependent on the rendering device, whereas PDF documents are essentially render independent. Any PDF document will appear the same regardless of what it's rendered on. An HTML document can look vastly different depending on what device you view it on or what program you're using to view it. Consequently, PDF documents have a very fixed layout. There's really no way of making them flowable with the current paradigm. And HTML documents can be fitted to any screen size, and that's fine. But another consequence of this is that HTML documents look bad. It's difficult to impart good typography on them. And PDF documents can look very good. So these two document paradigms have existed for the last 20 years or so. And as John Warnock was saying yesterday, it's time for a new format or something's got to change because HTML doesn't work very well. It doesn't look nice. PDF, although it looks nice, you're stuck with one fixed size document. So why don't we just improve HTML renderers? Well, we could, but typesetting is complex. The line breaking algorithm developed by Knuth and Plass runs in polynomial time, and the actual algorithm used by Tech is even more complex than the generic Knuth-Plass one. So this is very slow to run on the fly. So if you have your Kindle and you want to use the Knuth-Plass algorithm to break the lines, it's going to be slow. You may have used Adobe InDesign and have edited some text, and it's quite noticeable how if it has to recalculate hyphenation points and so on, that it's quite slow. It's not a quick process. So currently, eBook readers will use this late processing. So rather than the document being pre-compiled, all the hard work's done beforehand. We've now moved the hard work to the view time of the document. So we're basically all the work is now being done at runtime, and that's not ideal because, as I said before, these devices are battery powered. It's going to run your battery out. So what can we do instead of this? Well, we should probably take a lesson from history. So until around 30 years ago, newspapers were still being hand typeset. As Fabio was saying, there's galleys. So I'm using the term galley slightly differently to Fabio. He was using it as the actual content area. When I use the term galley, I'm specifically referring to some text that has been set into this area and is fixed. So in any case, newspaper text could be set into long galleys, so effectively one long column. These could be easily broken between lines to fit into the final newspaper layout. So an article could be continued on another page or another column on the same page. So it's simple to effectively flow this text into other places without needing to expensively retypeset it. So if we do pre-render the document text into galleys like this and have each line independently renderable, it makes layout very simple. We can just lay the text out line by line, and if we run out of space, or if we can either move to another, the text can be paginated to a new page, or if the content space is wide enough, we can lay out the text in multiple columns. This still doesn't quite work, however. It only fits on a very limited subset of screen sizes. Now, as the page width increases, which is along the bottom here, well, as the width gets to the width of one galley, we can then fit in one column. Now, this graph is showing the extra white space that needs to be inserted on the page to fit two columns in. So, as we get to the width, as we get from so the width, we've got the page is the width of one galley. As we increase it, the extra white space goes up, and then we get this sawtooth pattern as we increase the page width. So, well, we thought, well, why not embed several galley renderings into the document? So we can embed, say, 5 or 6 different width galleys into the document, all of the same content. And readability studies have suggested that around 30 to 80 characters per line is a sensible amount, and your eye can still follow it to that point. So at layout time, we can choose the most appropriate galley width, which can be based on some function of the screen width. If we want to change the point size, well, we can just scale a small galley up to create a larger point size, or scale a large galley down to reduce the point size. And layout at view time now is linear, and that is based on the number of lines on the page. Crucially, it's not the number of words or the number of letters. So it's very, very simple. And we've now shifted all the heavy lifting for the document back to compile time. So it's pretty much trivial to render the document on the device now. So here's just a visual example of how a short document could be rendered into 3 different galley widths. So there's a narrow one here, slightly wider one, and an even wider one. So each of these grey boxes can represents a line of text. We can just lay these lines out. You don't need, obviously, you choose the most appropriate one of the 3 to display, depending on how wide your page is or how wide your screen is. So we need some method of choosing which galley width to render. Now, we decided that we would like to penalise extra white space on the page, but try to favour fewer columns. So if 5 columns, 5 narrow columns will fit on the page with the same amount of extra white space inserted as 3 wider columns, we'd rather have the 3 wider columns. So our penalty is fairly simple. It's essentially the white space, the extra white space required to be inserted, multiplied by the square root of the number of columns. This is just an arbitrary choice. It's a factor which is smaller than linear, so hopefully, if the factor was linear or larger, we'd this sawtooth pattern would tend to wander off upwards. Now, if we, okay, I'll explain what this line is showing. This particular line is showing the penalty for a galley which is 15 ems wide at varying page widths. So if we insert 4 more galleys, which are slightly wider, well, we can overlay these penalties, and the way we choose the galley is to simply pick the smallest penalty at any given point. Okay, so this graph is in the paper. Hopefully this should explain how I created this graph. Essentially, we've just picked the lowest point of the upper graph and displayed it on this lower graph here. And the color matches up with the 15, 18, 21, and 24 em column width. So as we increase the page size, we'll flip between the galley renderings, and the number of columns will change at each of these transition points. So within these colour bars, we'll just be adding extra white space, but at the transitions we'll flip to a new number of columns. So how do we implement this? Well, currently we are using PDF as a container, and it runs inside Acrobat with a custom plugin. The reason we're doing this is because at Nottingham we've got pre-existing tools for creating modular PDF. My supervisor, Steve Bagley, has written a suite of tools known as what's called Cog PDF. He's presented it at DocEng several times before, which we just use to encapsulate the document components, so the lines of the galleys. I had to modify this to embed the paragraph structure within the document so that we can always keep track of which line belongs to which paragraph, so we know where to insert extra space. And if the page size changes, we know where roughly where to continue displaying the document if we're on a second page. So the Acrobat plugin just lays out the lines according to the page size and the paragraph structure which is embedded in the document. So here's a few examples. Now this is an iPhone size screen. We can drag the window slightly bigger into a Kindle size. You can see it's chosen a wider column. This is how it might look on an iPad. It's put in 2 columns. If you turn the iPad landscape, we've now got 3 columns. We can make the screen a bit bigger, so this is approaching a PC size screen. Slightly bigger again. Well, it's chosen a wider column variant. Bit bigger. Well, it's decided that more narrower columns is more appropriate here. So yeah, the actual metric, the penalty we've created may not be the best. We can work on it. But it's a proof of concept, really. So to extend this, we may be able to not treat the galleys as totally concrete. We may be able to tweak the justification slightly. So we can include hints which can be passed to the renderer to change the word spacing, the letter spacing, or even the glyph width to some extent. Also, currently the system doesn't really allow typefaces to be altered, but then neither do PDFs and neither do actual real books. So, but we could potentially render it in multiple typefaces. Obviously, it'd have to be a limited selection. But if it was needed for accessibility, for example, it wouldn't be a problem. It also may turn out to be wise for us to tailor documents to specific device profiles. So we could provide images at different resolutions or an appropriate range of galley width renderings. And obviously we could look at more exotic layout options than just laying out text in columns. So we could allow images or figures to be spanned over multiple columns. We could allow arbitrary layout with using something like Adobe's CSS regions model. Or we could use any of the examples we've seen yesterday and today, as long as they're not too costly, because then we lose the benefit of pre-rendering our lines. And obviously we need to implement this on a real eBook platform, because at present, well, it's very nice having it run in Acrobat on a PC, but it's not very practical or useful. So in summary, well, this system allows us to shift all the hard work from the viewing device back to the document at compilation time, but we've still got reflowability. And obviously, unlike an HTML-based ebook, the author and publisher can see every rendering of their document, so there's high quality control for them. And really, we're trying to work towards a truly portable document format. Thank you very much.
Question?
So there was a really good review paper a couple of years ago, and it mentioned a paper by Hirschberg and Lamore, which gives a linear time algorithm implementation of the tech line breaking algorithm. Given that and the fact that the CPUs on even the smallest, cheapest devices are getting much faster, and almost all the time is spent doing the graphic layout rather than the computing of the positions, I think you need to keep going for your research. I think you need to think a bit bigger before you get settled down too much in this area. Like, I think you need to think where you're going with this. It's not really a question, it was more just
I was going to say.
I
I haven't actually read that paper. I mean, I probably should now. But yeah, I'll take your feedback on board. Thanks.
So you compare the PDF model to the HTML model, but I think there's a model in between. It's called SVG. With SVG, you can render line by line. You can switch between two so it looks like it could be a technology for that.
But if you want to work out good places for line breaks, it's still as expensive as the HTML model.
I understood that you do your line break beforehand, right?
Yeah. Line breaking, hyphenation, you can insert ligatures where required, you can kern things properly.
Yeah, so you do that on the server.
Well, yeah. When the document's compiled, yes.
Yes, so you can do that processing on the server, produce SVG that's pre-rendered, and then just render the SVG.
Well, okay, that's another way of doing it, but we've done it in PDF. There's no particular reason for that.
Yeah,
it was just because it was
practical
easy.
reason.
Well, okay, we could do it in SVG, but I don't think the model, the Galley base model, has really been exploited before, or not in this way anyway, as far as I'm aware.
Thank you.
Okay. Any other questions for the speaker? Let's give him a hand.